Hi there, and welcome to tutorial number 1. When I first decided to revisit this snake racing game, I had a vague idea of what I wanted to do. I knew that I would need to get the final race times for each snake, compare them all in order to find out who was first, second, third, fourth and fifth, and then eventually pass these values through a condition node in order to return the finishing positions for each snake, and then from here pass these to a text spline to display them. And as a starting point, that was about as much as I knew. That being the case, I needed to work out how to get from A to B, so it was the middle part that I needed to get to grips with. Therefore, what I decided to do was revisit my earlier game where I only had the 2 snakes, and just begin working with a couple of proxy objects, and at first I simply used a couple of spheres, which is what I'm going to do now. So I've got my 2 spheres and I've changed their colours to pink and green simply by using the display colour. And the objective in this tutorial is to move them along their x-axes from 0 to 1000 centimetres and effectively race each other. So that's what we're about here. For a start, we'll just go into our green one here and get a tag for our Expresso expression. So in order to get the green one moving, all we need to do is get ourselves a time node for a start, and we'll add a frame output. We do need both time and frames actually. So we've got that in place there. The next thing we need to do is get a logic compare, and we're going to compare the frame value, and we'll change the function to greater than or equal to. And we're going to use 1 as our value, and there is a reason for this that I'll explain later in the tutorial, but for the moment we'll just put the 1 in there. So that's got things started. Moving on from here, we need to get ourselves a monoflop. So we'll get one of those, and we need to plug the output of the compare into the trigger, and then set the monoflop to one-shot mode. Setting the monoflop to one-shot mode means that it will be triggered when it receives a bool value of 1 at its trigger input. If it's left in normal mode, it will be triggered when it receives a 0. So there's a very important difference between the two that you need to be aware of when setting the monoflop up. We then take the time output from the time node, plug it into the monoflop's time input to give us a start point from when it's triggered. And finally, we need to give the monoflop a duration. We can't plug anything into there at the moment, so we're just going to give it a duration of 90 frames as a starting point. We also need to add a state output, because we're going to be using that with a range mapper in a moment. In fact, it's our next port of call. So we'll get ourselves one of those, calculate range mapper. Now the state outputs a factor value between 0 and 1. So we can plug that into the range mapper's input, and our input lower and upper values are already set to 0 and 1, so there's absolutely no need to change those. Everything's fine there. Our output lower can remain at 0, our output upper needs to be 1000, and we can then, just to get things moving, we can drag the green sphere in, go to coordinates position, position X, and we can then go on to connect the output from the range mapper to the position X's input on the green sphere. And now we get our sphere moving. Okay, so that's the first stage complete. Of course, we want our sphere to move over a certain duration, and once it's moved from A to B, we want it to hold its final position. As it stands, that won't be working yet, because we've got nothing to force it to stay at position B when it's completed the race. So as soon as we hit 92 frames, it jumps back to its start position. The reason for this is that once the monoflop has completed its cycle, it resets itself back to 0, and it does the same with the range mapper. We need to work around this. So what we need to do in order to prevent this from happening is add 2 condition nodes. We'll get the first one, go down to logic condition, place this one up here, just move everything down a little bit. Now this condition node is going to be used to set the start and finish points. So I'm going to connect the output of here, the output of the compare, which of course initially is going to be 0 because the time is going to be 0. which means we're going to start by using the value set in input 2. So we can leave that at 0 because of course we want the start position to be 0. And we'll set input 3 at 1000. So this condition is storing our start and finish points of the sphere. And that's all its job is. The second condition that we need to set, and I'm just going to copy this one over. We don't need the 1000 in there, so I'll take that away. This one's going to be switched by the monoflop from this out here. Now, this out port here generates a bool value. So before the monoflop is triggered, it will be 0. Once it's been triggered, it will be 1. So as before, we can use it to switch our condition between input 2 and input 3. So when the monoflop's been triggered, from that point onwards, the range mapper is being used because obviously the state value is being passed to it. That being the case, the range mapper's output should be plumbed into input number 3 because this is being used at the trigger point. Now at the points where it's not being triggered, we need the output from the first condition node plumbed into the input number 2 of the second condition node here, because it's either going to be that the sphere will be at its start position or its end position based on the compares output. If we then take our green sphere and plug the output from our second condition into here, we'll get the result that we need. So now, when we play this through, the green sphere reaches its endpoint and stays there. Even though we're way beyond 90 frames now, it holds its position. And when we reset our timeline to 0, it'll be switched back to its start position because our condition here is switching between the start and end points at the correct times. So that's the first little part of our expression there. Obviously, we've got to apply this to the pink sphere as well, but we'll do that in a minute when we've completed the next part of the expression, because there's a little bit more work that we need to do yet. Now, it's important that we vary the amount of time that it's going to take each of these spheres to get from A to B, because obviously if they always take the same time, they're going to tie with each other every time. We don't want that. So the way we're going to achieve this is to generate a random number. Now I'm just going to move this over and make it a little bigger because we've got a few more nodes to put in. Just bring that up to there. So the next port of call is to go across to here. Actually, we've got a couple of things to do, but I'm just going to go across to the X pool and I'm going to bring in a random integer and place that about here. Next thing I'm going to do is bring in a random node. So I'm just going to go down here and grab hold of one of these. So I've got a random seed value there. At the output stage, I want an integer. Just going to make that bigger. That's better. Okay, and I'm going to plug the random integer output here into the random seed input of the random integer node. So that's the first little bit of the next part of our expression. Now, in the random node, I'm going to leave, just move this out of the way, just leave the random seed value at 4711, that's fine. I want positive values only, that's quite important. I don't want any negative values. And in the random mode here, I'm going to select free mode. Now the difference between time and free modes is quite simple actually. In time mode, the animation will always be the same whenever you run it because it always generates the same random numbers at any point in time along the timeline. With free mode, the direct opposite is true, so it always generates different random numbers every time you run the animation. So you never get the same animation twice, and that's important. So that's done. The next thing to do is to get a math node, because we need to add the value from the random integer here into the math node. Just going to plug that into there. Before I go any further though, I'm just going to go back a stage because I've missed a little bit. I just need to set up this random integer. What I'm going to do, I'm going to put minus 10 in the lower limit and then 10 in the upper limit there. And what we're going to do here is add plus or minus 10 frames to the number of frames to the duration that we've got for the sphere to move from A to B. So that's what we're doing here. We're creating a variance in the time that it takes the sphere to cross from its start position to its end position. So in the math node, I'm going to put 90 in the input there because we've got 90 frames as the basic amount of time that it would take the spheres to get from A to B. So we'll add plus or minus 10 to that. So that completes that part. The next thing I need to do, I'll just command drag this to copy it. I'm going to change the function here to a divide for this particular node on this occasion. Take that away. I'm going to plumb the output of the math add into the top input there, and I'm going to divide by 30. What I'm doing here is actually turning frames into seconds because I'm working at 30 frames per second here. So I'm dividing my frames by 30 to return the correct number of seconds at the output from the math divide. And that's important because the monoflop, as we've got it set up, has a duration of 90 frames. Now, frames is fine when you're using the parameter box here. However, when you plug anything, and we're going to plug the output of the, well, not the divide node actually, but I'll just plug this in there as an example. So when you plug anything into the duration input of a monoflop, it must be expressed in time, as in seconds. So that's why I've done that. It's just something that you need to bear in mind. I'm just going to disconnect that for a minute because there's one more node that I must add, which is a freeze node. So I'm just going to go across here, come down to General, and get myself one of those. Now this freeze is going to be useful to us because we only want one random value generated, just right at the beginning of when we actually set this in motion. So what we're going to do, just move this across here a little bit. We've already set this up to greater than or equal to 1, and I said that I'd explain why later, and this is the point at which I am going to explain why. So the reason I've done it is because I only want to generate a random number at the first frame. So what I'm going to do, I'm going to plug this into the switch. Therefore, the freeze node after one frame is going to be switched, which will mean that any value currently passing through the freeze node will then be stored within it after one frame, and any subsequent values after that one frame won't be allowed to pass through the freeze node. So if you're looking to generate a single random number, this is the best way to go about it. So that completes the next part of our algorithm. Moving on from here, we can take the output of the freeze node and plug it into the duration of the monoflop. So that's that little bit of it sorted out. And now if we run our timeline, I'm not sure how many frames that took. Let's just do that again. Let's just run that from there and see how many frames it takes to get from A to B. Okay, it took 87 frames. It stopped at 87. I'm on frame 88 now. So it was -3. That being the case, -3 would have come out of the random integer here. That would have been -3. Okay, that explains how that works. We also now need to apply this to our pink sphere. So we'll just drag this down there. And all we need to do to make this work with the pink one is just go over here and drag the pink one in there. And that sets up the pink one. The only thing we really need to change now to get it to go is the random seed here. If we just change this value here, and we can change it to whatever we like, I'm just going to use 6735. This enables us to be sure that they don't always get exactly the same number. So let's just run it and see what we get. Right, you can see there's a variance and the green has won there. Let's do it again and see if we can get the pink one to win. Oh, no, and the green one's won by an even greater margin that time. Now they're almost neck and neck. Green's going to win again. I'll be here about half an hour trying to get the pink one to win now. But I can assure you the pink one will win. There's definitely no bias in it. Oh, here we go. The pink's going to win this time. That's great. So that proves it works up to that point. However, it's all looking a little bit linear at the moment, and it's not very exciting to look at, is it? Well, the good news is that we can change that very easily. All we need to do, we just have to go into our range mapper here. Now we've got use spline here checked, which is important because we are going to be using the spline, but we've got nothing in there at the moment. What I'm going to do, I'm going to hold down my command key and click on there. Click on there. So I've got a couple of points. And if I bring point 2, so it's point number 1 over here and point number 2 over here. If I bring point 2 up there, that gives us an ease in and ease out curve on the spline of our range mapper there. If I now go into my pinks range mapper and I do exactly the same thing, that gives us those two there. And this is not what we're going to end up with, it's just to give us a starting point for it, that's all. So if we run the timeline now, they both ease out and they both come to a nice smooth standstill. It's not perfect, but it's better than it was. And I think we can say it's a little bit more interesting too. And pink appears to be on a winning streak by the looks of it. Oh no, green's going to take it this time. Okay, great. So we've got it a little bit further. Just stop it there and take it back to the beginning. But to make it really interesting, we're going to do some advanced work with the range mapper, and we'll move on to that in our next tutorial.